How to find the value of RMS of a sinusoidal waveform in electrical AC system. This tutorial lesson will guide you to learn. I had made a graphically animation that you can visualize and clearly understand. As you can see in this video, it is expressed the periodic time of the waveform. It is measured either in degrees or radians, as one full cycle is equal to 360 degrees. This is horizontal axis, from 0 degrees to 180 degrees, is the positive half cycle. Below the horizontal axis, from 180 degrees to 360 degrees, is the negative half cycle. How do we calculate it, the RMS value of this sinusoidal waveform? The RMS value of a sinusoidal or complex waveform can be calculated by two methods. First is the graphical method, which we can calculate the RMS value of any non-sinusoidal time-varying waveform by drawing a number of mid-ordinates onto the waveform as shown. Second is the analytical method, which we can do an advanced mathematical procedure for finding the RMS value of any periodic waveform of a voltage or current using calculus. It is the accurate method that can be defined for a continuously varying function in terms of an integral of the squares of the instantaneous values during a cycle. From this whole graphically waveform, we will consider only the positive half cycle for finding the RMS value. Since these two halves are exactly similar sinusoidal. Now, let us proceed first the graphical method for finding RMS value. You can see this waveform. This is the positive half cycle from 0 degrees to 180 degrees. Please watch the full tutorial, if you wish to learn. The RMS value of a waveform can be found by taking the equally spaced instantaneous values along the waveform. As you observed, the instantaneous values of V1, V2, V3, up to V36, is directly proportional to the peak voltage, Vp, and angles, sin theta. This is the value of equally spaced mid-ordinates. First, get the equation for average or mean values, by using equally spaced mid-ordinate rules. The sum of total V1 to V36, is divided by the number of mid-ordinates as given. Second, we can define the term RMS value as being the square root of the mean of the square, this is given as. Third, so let's taking 36 mid-ordinate values, is found in this sample waveform to vary over one half cycle as follows. Let's find the equation of instantaneous values, as given angles in the equally spaced. V1 equals Vp, as peak voltage, times sine of 5 degrees. V2 equals Vp times sine of 10 degrees, up to the value of V36 equals Vp, as times sine of 180 degrees. This is the equation of RMS equal to the square root of squared part of instantaneous values of mid-ordinates divided by 36 the number of mid-ordinates. As shown on this table, the list of value of V1 sine of 5 degree, V2 sine of 5 degree, up to V36 sine of 180 degree. Then, do the squared of all values, as shown in this data result. Next, add all the values, the total sum is 18 Vp. The result of RMS is equal to 18 Vp divided by total 36 mid-ordinates. Then, do the square root. The value is 0.7071 times Vp. For much easier calculation, do the 12 equally spaced mid-ordinates. That's our lesson for today. We will discuss next video, the analytical method of calculation. Thank you for watching. See you again.